Welcome to Ecosystems Model Part 4, Cycles of Matter in an Ecosystem. Be sure you have your notebook as well as your energy flow chart. In this PowerPoint, we will be focusing on the question, how is the flow of energy within food webs interconnected with the cycling of matter? To address this question, we will be looking at the importance of the water cycle, nitrogen cycle, and carbon cycle in an ecosystem. In your notebook, copy the guided questions in Cornell Note style. As you go through the PowerPoint, answer the questions. At the conclusion of this PowerPoint, show your teacher your answers. Locate your ecosystem flowchart. In the oval labeled number 3, copy the appropriate heading. As we go through this PowerPoint, we will be discussing the importance of the water cycle, the carbon cycle, and the nitrogen cycle. So let's begin the cycling of matter in the ecosystem. Matter, such as energy, cycles throughout our ecosystem. All material that cycles through living components in our ecosystem are very important to maintaining the health of that ecosystem. But there are 4 substances that are of particular importance that we are going to discuss in this PowerPoint: water, carbon, nitrogen, and phosphorus. The biosphere is part of the earth where all living things exist. There are 5 ecological cycles that support the biosphere: carbon cycle, phosphorus cycle, nitrogen cycle, water cycle, and the oxygen cycle. Where does matter cycle in an ecosystem? That's pretty easy. It cycles everywhere. It is a global recycling that takes place. The earth recycles nutrients throughout its various spheres. In the atmosphere, which is the air, the lithosphere or geosphere, which is the land. Recycling occurs in the hydrosphere, which is the water, as well as the biosphere, where all living organisms exist. These elements and compounds that are recycled are crucial because they're needed by organisms to live, grow, and reproduce.
While energy flows through ecosystems, a number of other substances are recycled and never lost. Water, a necessity of life for all living things, is constantly recycled. It can lie in a lake for a time and then flow into the sea. It evaporates into the atmosphere. The wind blows the water vapor a distance and then it falls as rain. The water can remain in the soil, be absorbed by plants and drunk by animals. It is constantly being recycled, not only through ecosystems, but also through the entire biosphere. The carbon cycle is based on carbon dioxide, CO2. During photosynthesis, producers, such as plants, build carbon compounds. When plants are eaten, the carbon is broken down by cellular respiration and used as energy by other organisms, but most is released into the atmosphere or into the oceans where it is recycled. Carbon is also trapped in fossil fuels such as oil and coal. When these fuels are burned, they release the carbon into the atmosphere. Over time, the carbon dioxide has built up in the atmosphere to produce what is called the greenhouse effect and global warming, one of the most serious environmental problems that we are facing. At the local level, ecosystems can be overwhelmed by heavy concentrations of any of the elements that enter the system. For example, nitrogen makes up 78% of the Earth's atmosphere, but only very small amounts are in the soil, oceans, and organisms. It is recycled through ecosystems by some plants, bacteria, and decomposers. In recent years, large amounts of nitrogen fertilizer has been added to the soils to increase crop production. This is leading to the acidity of soils and the pollution of watercourses. Phosphorus is also required as a nutrient for plants, and like nitrogen, it is being added to soils in fertilizer. Runoff from farmland containing these two chemicals overstimulates algae growth in lakes and rivers. This robs the water of oxygen and suffocates the aquatic life.
The water cycle, also known as the hydrologic cycle, moves water throughout the earth. The vast majority of all the water located on Earth is found in the ocean. So that means that approximately 97.5% of our water is salt water. The remaining 2.5% is fresh water, and that water can be further divided. The water cycle is very important because all living things need water, and water and its availability has the greatest influence on the ecosystem's inhabitants. In the water cycle, water vapors cool in the atmosphere and condenses to form clouds. Once clouds become saturated or too full, moisture falls to the earth in the form of precipitation. Some of this water soaks into the earth or infiltrates and becomes part of the groundwater, that is, water below the earth's surface. Other water flows across the surface of the land as runoff and collects in surface water, which are your lakes, your rivers, and your streams. Most of the remaining water that falls to the earth does not stay on the surface. Driven by the sun, this water is heated and re-enters the atmosphere through the process of evaporation. Much of the water is taken up by the roots of the plant. After passing through the plants, the water moves into the atmosphere by evaporating from the leaves of the plant. This process is called transpiration.
In this program, we're going to talk about the water cycle. What is the water cycle? The water cycle is the movement of water from the Earth's surface into the air and back to the surface again. Water on our planet is always moving. Water moves from the oceans to the clouds to the land and rivers, then back to the ocean. This process, called the water cycle, is repeated over and over and over again. The key stages of the water cycle are evaporation, condensation, precipitation, and collection. Water travels up into the sky through the process of evaporation. Evaporation is the process by which liquid turns into a gas. Evaporation happens when the sun heats up water molecules and turns the liquid into a gas called water vapor. Vapor rises into the sky. While in the sky, water vapors cool off and change back into a liquid through a process called condensation. Condensation is the changing of a gas into a liquid. When so much water has condensed in the air, the clouds get heavy, and water falls to the earth as precipitation. Precipitation falls from the clouds as rain, hail, sleet, or snow. The water then flows back to the oceans, and the water cycle begins all over again. Evaporation, condensation, precipitation, and collection. Now that you better understand the water cycle, think about this. Why is the water cycle so important to life on Earth? Think about it.
Review the key processes in the water cycle: precipitation, evaporation, transpiration, and condensation. The next cycle for discussion is the carbon cycle. The carbon cycle involves both photosynthesis and cellular respiration because both of these processes involve carbon dioxide. The carbon cycle is an important cycle because carbon is the building block of life, meaning all living things contain carbon. Carbon, like water, also cycles between the living and non-living factors in an ecosystem. So the carbon cycle is a cycle that moves carbon from the atmosphere through the living components in the food web and then returns it to the atmosphere. When analyzing the carbon cycle, there are two questions that need to be answered. One, what process removes carbon from the atmosphere? And two, what process adds carbon to the atmosphere? Photosynthesis removes carbon in the form of carbon dioxide that is in the air or dissolved in water to form the organic molecule glucose. Carbon atoms are returned to the air and water in four ways. One, respiration. Secondly, combustion. A third way, decomposition. And a fourth way, erosion. In respiration, organisms take in oxygen to break down glucose during cellular respiration. Carbon in the form of carbon dioxide is produced during this reaction. For combustion, organic material are made of carbon. So when wood or fossil fuel is burned, it releases carbon back into the atmosphere. And with decomposition, when organic tissue and waste are broken down by decomposers, they release carbon back into the soil. In erosion, marine organisms use carbon dioxide dissolved in water to make calcium carbonated shells. When these organisms die, the shells form limestone sediment. As the limestone sediment becomes exposed, it erodes, thereby releasing carbon back into the water.
Chemically speaking, all life is based on carbon. This element of matter moves through ecosystems in what is called the carbon cycle. The carbon cycle starts with air, because air contains carbon dioxide gas, a chemical compound made from one atom of carbon and two of oxygen. Land plants absorb carbon dioxide into their leaves and make sugar and other carbohydrates that can chemically store the sun's energy. Carbon dioxide also diffuses into water where it is used by aquatic food producers such as seaweed. When organisms feed, they obtain both the chemical energy stored in carbohydrates and the carbon atoms the carbohydrates contain. Some carbon atoms are used to build body tissue, and others are released back into the environment as carbon dioxide when living things use chemically stored energy. Carbon is also returned to the environment when wood or fossil fuels are burned, and when decomposers carry out the process of decay. The carbon cycle clearly illustrates how the materials of life, in this example, carbon atoms, are borrowed for a while by one organism and are passed on to others through food webs, or else are returned to the physical environment where they can be used again by other living things.